Hey guys, welcome back sa ating channel. So, for today's video, mag-solve tayo ng deflection at slope of a simply supported beam or a simple beam using double integration method. So, meron tayo ditong sa simple beam with a concentrated load at mid-span na load P. So, sa double integration method, ang first step is kukumpute natin yung mga reaction sa supports. Since simply supported ito, meron tayong hinge and ruler support. So, alam naman natin sa hinge support, meron tayong dalawang reactions. So, vertical reaction and horizontal reaction. Then dito sa ruler support, so meron lang tayo diyang isang reaction. So, RBX, BY, and RA. So, gamit yung equation of equilibrium, makumpute natin yung reaction at A by summation moment at B. Summation moment at B, clockwise positive yung assumption ko. So, RA times L, yung distance niya from point B, minus P times L over 2 minus 0. So, calculating or rearranging the equation, so, makukuha natin RA is equals to RBY is equals to P over 2. So, equal lang sila sa paghahatian lang ni RA at saka ni RBY yung P, since sa gitna yung ating P. So, sa double integration method, so, nagkakat tayo dyan. So, nagkakat tayo dito sa closest to the right support. Then, yung RA, may distance siya sa point na to. So, ilagay natin anong distance? X. Then, si P, ganun din, meron siyang distance dito sa point na to na X minus L over 2. Tama? So, dito kasi tayo mag-moment sa point na to. Okay? So, ito na yung ating simple beam. Nagka tayo doon sa close. Malapit sa point B. So, meron tayong reaction at A, which is yung P over 2 nga, na-complete natin. So, ito yung anong distance X and X minus L over 2. So, moment, mag-moment tayo dito sa point na to. Moment is distance P over 2 times distance X. So, RA times X. So, minus, since P is counterclockwise, so minus P times yung distance niya is X minus L over 2. So, yan. So, then, integrate natin yan. That is our equation, moment equation or equation 1 natin. So, integrate natin yung equation 1. So, gagamitin na natin yung power rule. Recall lang natin yung power rule sa integral calculus. So, integrate of x raised to n is x n raised to n plus 1 over n plus 1 plus constant. Huwag natin kakalimutan yung constant. So, integrate natin yan. Makukuha natin yung slope equation or yung integral ng ei double prime magiging ei y prime na lang. So, RA, x. So, anong integral ng x is x squared over 2. So, RA times x squared over 2. Ganun din sa x minus L over 2 is x minus L x squared over 2. Yun. X minus L over 2 squared over 2 plus constant 1. So, yung kung natin kakalimutan yung constant, that will be our slope equation. So, integrate natin itong slope equation. So, makukuha natin yung deflection equation. Or deflection or EIY is equals to RA magiging x cubed 3 times 2 is 6. So, RA x cubed over 6. Ganun din dito. Minus P x minus L over 2 raised to 3 over 6 plus constant 1 times x plus constant 2. That will be our third equation or deflection equation. So, kailangan tumama kayo dito sa mga equations na to kasi once na may sumablay dito sa equation, so, malaki ng epekto dun sa magiging solution natin. So, yun yung tatlong equation pinakamahalagang gagamitin natin. Then, ito na yung ating simple beam. So, meron tayo, syempre, due to its load P, so magdi-deflect ito. So, ito yung elastic curve. Yan yung, nirepresent niya yung deflection ng ating beam. So, meron tayong mga tangent lines, tangent at A o tangent at B. Nakatangent din sa ating elastic curve. So, which is ito yung ating slope A, ito yung ating slope B. Okay? So, gamitin natin yung mga boundary conditions. So, first boundary is yung A. Dito. Dito sa A, ang x dyan is 0. Tama? At x equals to 0, so moment dyan is 0. Tama? Then, meron dyang slope. Slope is not equal to 0 kasi nga, mayroong value yung slope A. Then, deflection is 0. Walang deflection sa ating supports. Dito walang deflection, dito wala rin deflection. So, pwede natin gamitin yung deflection equation. where yung deflection equate natin sa 0, then yung x equate natin sa 0, 0, 0, 0. So lahat 0, makakompute natin sa C2 is 0. Use the next condition, yung at x equals to L, which yung tinutukoy is dito, point B. Ganun din, wala rin yung moment, pero mayroong slope, tsaka wala rin yung deflection. Tama? Then gamitin din natin yung deflection equation. Yung x, palitan lang natin ng L. So, ganito yung mangyari. P over 2 times L cube over 6. Yan. Palitan nyo lang yung x ng L. So, yan mangyari. Then, i-rearrange natin yung equation natin. So, ganito yung mangyari sa atin dyan. P over 2, L cube over 6 minus P times L minus L over 2 times L cube over 6 plus C1 times L plus 0. 0 na yan C2. So, rearranging the equation, P over 2, magiging PL cube over 12 minus P, L minus L over 2 is L over 2, cube over 6 plus C1 L. So, PL cube minus PL cube over 12 minus PL cube over 48. Kasi 2 raised to 3 is 8 times 6, 48 plus C1L. Pwede natin transpose yung C1L. Pwede natin transpose sa kabila. So, magiging C1 times L is equals to PL cube over 48 minus PL cube over 12. So, nilipat natin sa kabila. Kaya, naging positive yung negative is naging positive. Ay, yung positive naging negative, yung negative naging positive. So, yun na. Divide natin both side ng L. Magiging C1 is equals to PL squared na lang over 48 minus PL squared over 12. So, gamit natin ng 1 minus PL cube over 12 magiging 3 PL cube over 48. Okay? Kasi si 48 na pag ginawa natin yung this common denominator nila is 48. So 48 PL squared over 48 minus ng 4 PL squared over 48 kasi 4 times 4 is 48. So magiging negative 3 PL squared over 48. So this common ng simplest form is magiging negative PL squared over 16. Kasi 48 divided by 3 is 16. So okay, sana malinaw ito, no? Pagkuha natin ng constant. So mahalaga yan. So next, proceed tayo sa ating deflection equation. Para makapit natin yung equation. Ano ba yung formula ng maximum deflection kapag ganito yung loading. So substitute lang natin. Ngayon, hindi natin alam kung saan yung location ng maximum deflection. So dito sa problem natin, sa example natin, since symmetrical siya, alam natin na nasa gitna yung maximum deflection. Tama? Kasi symmetrical. Ibig sabihin, ano kasi yan, sa lowest point kasi ng ating curve, at the lowest point, ang slope doon is 0. Kasi yung slope, yung tangent line natin is vertical. So, 0 yung slope sa location ng maximum deflection, therefore x is equal to L over 2. Dito yan, ibig sabihin, maximum yung deflection dyan. Kasi nandiyan yung lowest point ng ating elastic curve. Okay? At x is equal to L over 2, the deflection is maximum. So, substitute lang natin si L over 2 kay x, magiging P over 2 times L over 2 cube over 6 minus P times L over 2 minus L over 2. So, ito ay cancel na. Kasi L over 2 minus L over 2 is 0. So, rearranging the equation, P over 2 times L over 2 cube over 6 plus C1 times x, where yung x is yung L. Magiging P over 2, L over 2 cube over 6 plus C1 L over 2. Magiging PL over PL cube over 8 kasi 2 cube is 8 over 12. So 8 times 12 magiging 48 yan. So magiging PL cube over ng ano pala 96. PL cube over 96 minus PL cube over 32 kasi 16 times 2 is 32. This common denominator is 96. Magiging ganyan. PL cube over 96 minus 3 PL cube over 96 kasi 96 divided by 32 is 3 times 3 PL cube. Magiging 1 minus 3 is magiging negative 2 PL cube over 96. So 96 divided by 2 is 48. So negative PL cube over 48. Therefore, ang formula po ng ating maximum deflection kapag nasa gitna yung concentrated load or sa mid-span is PL cube over 48 PI. So dinareg natin yung formula kapag nasa gitna yung ating loadings. Ngayon, Mag-try tayo ng isang example sa concentrated load, pero ang example natin is wala sa midspan. So, ibig sabihin yung ating elastic curve is hindi na siya symmetrical. So, try natin itong problem na to. A simple beam is loaded 150 kN at point B. Using double integration method, calculate the maximum deflection and slope at supports. So, ito yung ating figure. Meron tayong 150 kN at point B, 2 meters from point C, and 8 meters from point A. So, first step, compute for the reactions. Summation moment at C, makukumpit natin si RA. So, equations of equilibrium, ito yung free body diagram natin. Summation force X, so wala naman tayo, since wala tayong horizontal load, so Cx is 0. So, summation moment tayo kasi, clockwise positive, so RA, so AY times 10, minus 150 times 2, so calculating, AY will be 30 kN. The summation force vertical, so RAY plus RC is equals to 150. Tama. Kasi pataas yung dalawang force niyan. So, RC is equals to 120 kN. So, kung na-complete na natin yung reaction, so mag-cut na tayo. Magka-cut tayo sa closest to the right support, then this is X distance, and this X minus 8. So, then mag-moment tayo doon sa cutting point. So, moment is equals to 30 times X minus 150 times X minus 8. Then integrate. So, 30x squared over 2 minus 150x minus 8 squared over 2 plus constant. So, arrange natin yung ating equation. Magiging 15x squared minus 75x minus 8 squared plus C1. Then integrate ang ating slope equation. Makukuha natin yung ating deflection equation. 15x cubed minus 75 minus 8 cubed over 3 plus constant 1x plus C2. C1x plus C2. Then use the boundary conditions. Ating boundary conditions. At x equals to 0. So, 0 ang x. So, dito yan sa point na to. So, wala dyan deflection, walang moment, pero may slope. So, pwede natin gamitin yung equation ng deflection. So, 0. So, therefore, C2 is 0. Then, next boundary condition is x at is equals to 10. So, dito na may tinutukoy dyan. So, pagtanan natin yung lahat ng x sa deflection equation kasi sa point C, deflection is 0. So, makukuha natin si C1. So, 5x cubed minus 25x minus 8 cubed plus C1x plus C2. 0. So, makukuha natin si C1. C1 is equals to negative 480 kN per kilonewton meter squared po. Kilonewton meter squared. Sorry, nagkamali ako. Kilonewton meter squared po yan. So, hindi divide. Kilonewton times po meter squared. Okay? Correction. Next, i-locate natin kung saan yung maximum deflection. Kanina, nalaman natin by inspection na nasa gitna yung location ng maximum deflection kasi symmetrical yung ating elastic curve. At this case, hindi na siya symmetrical. So, gamitin natin yung kanina, sinabi ko na sa lowest point ng ating curve, kahit anong curve, yung lowest and highest point, ang slope dun is 0. So, ibig sabihin, at deflection equals to maximum, ang slope is 0. Tama. Kung nasaan yung location ng maximum deflection, ang slope is 0. Pwede natin gamitin yung slope equation. Na slope is equals to 15x squared minus 75x minus 8 squared plus C1. Kaso sa pagkuha ng x sa location, mayroon tayong mga assumption. So, ang first assumption natin, yung location ng ating maximum deflection is nasa pagitan ng 0 to 8. So, dapat ang in-expect natin lumabas is mababa siya sa 8, pero mataas sa 0. So, ibig sabihin, kung mababa sa 8 yung ating in-expect na sagot, so hindi natin to isasama. Kasi yun yung use ng symbol na to. Kapag nag-negative, hindi na siya isama sa equation. Ito yung ating assumption. Ng x is greater than 0 but less than 8. Pero kung ang lumabas naman is 8 point something pataas, so ibig sabihin, mali yung ating assumption. Ang location pala ng maximum deflection is mataas na 8 pero mababa sa 10. So try muna natin tong first condition. Kapag tumama dyan, so yun ang location ng maximum deflection. Sana naintindihan nyo. Yun po yung medyo komplikado sa DIM. So, kailangan marunong kayo mag-assume. Na-assume natin na dito lang magre-range yung location ng maximum deflection. Hindi siya lalampas sa 150 kN, kaya hindi natin ito isasama. Okay, gets nyo? Then, 0 is equals to 15x squared minus, so cancel na yon, plus C1 na negative 480. So, magiging equation natin is 0, 15x squared minus 480. So, ito ay quadratic equation. So, makakuha tayo ng dalawang value ng x. So, piliin natin yung positive. So, nakuha natin is x equals to 5.657 meters. So, pasok ba siya dun sa assumption? Yes, pasok siya kasi ang assumption natin is greater than 0 but less than 8. So, pasok ito 5.657 meters. So, yung x na yan is substitute lang natin doon sa formula ng deflection or deflection equation. So, yan. Hindi na natin isama itong x minus 8 kasi 5.657 minus 8 is negative. So, hindi na yun isama. Ganon sa DIM. Kapag negative, hindi na siya isama sa equation. So, magiging 5 times 5.657 cube minus 480 times 5.657 will give us negative 1,810.193 kilonewton. So, again, ito ay times kilonewton meter cube. Hindi po divide. Kilonewton meter cube. Or, final answer is deflection maximum is 1,810.193 over EI. So, downward. Ang ibig sabihin po ng negative sign sa DIM o sa double integration method is downward yung ating deflection. So, kapag positive, ibig sabihin upward. Okay? Now, kumpitin natin yung slope at A. Since slope at support A yung nahanap, so gamitin natin yung slope equation. Substitute lang natin yung x. Ano ba yung x sa slope? Sa support A, di ba 0? 0 lahat ng x. So, makumpita natin is yung matitira is C1 na negative 480 kilonewton times po yan, times meter squared. So, yan. So, kaya nag-negative, ang ibig sabihin po nun is clockwise ang ating ikot ng rotation ng ating slope. Okay? So, 480 over EI, yung slope ng ating slope at support A. Then, slope at support B, ay slope at support C pala. So, gamitin natin yung slope equation, 15x squared minus 75, x minus 8 squared plus C1. So, yung x natin is 10, substitute lang. Bakit naging 10? Kasi nga, 10 yung distance niya from point A to point C po to, is 10 meters. So, calculating, it will give us a value of 720 kilonewton times po yan, meter squared. So, but positive, ibig sabihin, counterclockwise yung rotation ng ating slope. Okay? So, sana naintindihan? So, yung problem na to, kapag yung ating concentrated load is hindi nasa gitna, kasi kapag nasa midspan, ang formula natin is PL cube over 48, which is yung dinerive natin kanina. So, ngayon, kapag ganito yung case, may formula ba? Yes, may formula. Ito yung formula. So, hindi ko kayo nire-recommend na mag-memorize ng maraming formula o mahabang formula. Kasi, papangarapin nyo pa mag-memorize ng ganyang habang formula. So, di ba? Kahit ako, hindi ko minemorize yan. So, since alam natin yung DIM or double integration method, so kahit natin ito alam yung formula na to, makakompute natin yung tamang sagot. So, di ba? So, hindi lang DIM yung pwede natin gamitin, meron pa tayong area moment method, superposition method, or marami pang method na pwede natin, na-discuss natin sa next video pa. So, ito po yung formula. I-try nyo pong gamitin ito sa ating problem. So, ang lalabasin dito is 1,810. Yung nakuha natin kanina. So, same lang po yan. So, kayo, kung masipag kayo magsaulo ng formula, pwede nyo memorize. Pero kung ako yung tatanungin, mag-DIM na lang tayo. Since, madali lang naman mag-integrate. Diba? Ay, paano kung mayroon sinama dito ang concentrated load, ay ng uniform load. Diba? So, hindi na to applicable kasi meron na siyang kasamang load na ibang load. Meron kasamang varying load. So, napakahassle kapag mamasa kayo sa formula. Since alam niyo yung method, so pwede niyo siyang gamitin kahit anong pang loadings yung nilagay dyan. Okay, sana nag-guess niyo yung point ko. Sana naintindihan niyo yung double integration method. So, sa next video natin, mag-try tayo na mag-solve ng uniform load and varying load using double integration method. Okay, so try niyo tong problem na to. So, 250 kN, so 9 meters from support A and 3 meters from support B. So, using double integration method, okay, try nyo solve. So, sana naintindihan nyo. Thank you sa panonood sa ating channel. So, huwag kalimutan mag-subscribe. So, 999,910. So, 1M subscribers na tayo. Thank you sa support.
I hate school, but
Tell me, why are we wasting time on all your wasted grind when you should be with me instead?